So today, section 2.7, graphing techniques. We have two types of graphing, which is the outside, or we call vertical techniques, and the horizontal techniques. We're going to use these techniques on any function. It depends. Remember yesterday we took the 6 functions. We're going to use these as a basic function to graph or using the techniques on these basic functions. Let's start. We're just going to do fast review about these functions because we're going to use it. And if you remember each function, I gave you the points to graph these functions. Let's start doing a fast review. So the first function, if you remember, we said f of x equal x. I gave you the points how to graph this function, and the graph is always going to be a line like this. The second function, f of x equal square root of x, or let's say the x squared. The graph of this function, I gave you the points to graph it. This is these parents function. The graph is going to be like this, always. The third one is f of x equal x cubed. The graph of this function, this side up, this side down. Number 4, f of x equals square root of x. The graph of this function is going to be just a line like this. Number 5, f of x equal the cubic root of x. The graph of this function, this side like this, exactly like this function, the x squared, but there is another side like this. And the number 6, f of x equal the absolute value of x, this graph like this, like a V letter. I gave you the points, the x and y for each function. So you're just gonna go back and check the x and the y if you wanna graph these. These called the parent function. We're going to see exactly the same function with extra parts. It's called the techniques. Let's study the techniques, then I'm gonna give you examples. So keep in your mind, these are the parent function. If you wanna just go ahead and graph it on piece of paper. So we're going to use exactly the same thing. Techniques. So these are vertical function. That means everything is gonna happen here is going to be vertically. That means the function is going to be moved up, down, reflect up, down, like exactly the same thing. So we're gonna start vertically, the first techniques here, and I'm going to write down the first techniques here, which is horizontally. So let's start. Here is the first techniques. Remember, these are the parent function. So I'm going to use the same symbol. F of x. F of x, it's mean the basic function, which is one of these. So if you see f of x, that's mean one of these parent function or basic function. So let's start with the first technique. When we have, this is the parent function. That's mean one of these 6 functions plus a number. So when you see one of these functions plus a number, that mean is going to be shift up. How many units? It depends about this number. Let's do the same techniques here. It says outside. That's why it said outside. That means the technique outside the function. The technique outside the function. Let's do the first techniques here. F to the x plus a. Let's write down here so we can make space. So this one is shift up. You see x between the parentheses plus the techniques outside. You see here x plus the number inside the parent function. So this one, be careful, is not shift to the right, it's shift to the left. Let's do an example about these two techniques. I was going to be shift right or shift left. So I need you to write down with me because I'm going to write down the examples here. For example, one of these parent function, let's say if you have square root of x plus 3. You see, this is the parent function of the basic function, which is the square root of x plus the number. That's mean you're just going to write down shift up. How many units? 3 units. Shift up 3 units. Another example, if you have x squared plus 3, this is the parent function, plus 3. That means also shift up 3 units. Let's do an example about that. If we have cubic root x plus 2, you see the number here inside the parent function. The parent function here is the cubic root of x plus the number. You see the number inside the parent function. That means it's going to be shift left. It's going to be the movement horizontally, left or right. The movement here is going to be vertically, up or down. So with this case here is going to be shift to left. How many units? 2 units. Let's do another example. If we have x plus 3 squared. Check the squared for everything here inside. That means x squared. The parent function here is x squared, but there is a number here. That's why the number exists inside the function. So we're going to call it, it's going to be horizontal technique. That means it's going to be left or right. It's a plus 3, exactly the same rule here. So we're going to say shift to left. How many units? Depends about this number, 3 units. So this is the first techniques about if it's outside, like these two examples, if it's inside, like these two examples. So the second techniques, if we have f of x minus a, shift down, f of x minus a inside is going to be shift to the right. Here's the examples. Square root of x minus a is going to be shift down 2 units. X cubed minus 4, you see the number is outside the parent function, so shift down 4 units. Now x minus 3, here's the square root, that means the number inside the function, so it's going to be shift to the right 3 units. Depends about this number, so 3 units, not minus 3 units, only 3 units. X minus 2, the absolute value of x minus 2 is going to be shift to the right 2 units. So this is the second techniques. When we have a number outside the function, is going to be vertical technique, and we have a number inside the function is going to be horizontal techniques to the right. If it's negative, it's going to be to the right. If it's positive, it's going to be to the left. Here with the vertical technique, if it's positive plus the number is going to be shift up. If it's minus the number is going to be shift down. If we have negative sign, so now if we have negative sign outside the function, if we have negative sign outside the function, it's going to be reflect over x-axis. That means you're going to reflect the function. Reflect over x-axis. If we have negative sign inside the function, for example, like f to the negative x, so it's going to be reflect over y-axis. Two more techniques, and we're going to get all the techniques, then we're going to do a graph. How to use the techniques on a graph. Let's do an examples about reflection. So you can understand the whole thing, how it looks like. For refraction over x-axis, for example, if you have negative square root of x, you see the negative outside the parent function. This is the parent function. So you're just going to say reflect over x-axis. Another example, if we have negative x squared, negative x squared. So negative outside the parent function. So it's going to be reflect over x-axis. The same thing with the other techniques, horizontal techniques. That means going to be reflect over y-axis. If we have cubic root of negative x, so it's going to be reflect over y-axis. The same thing with the square root. If we have square root of negative x, is going to be reflect over y-axis. So these examples about the reflection, and also when we do the graph, you will see more about how it's going to be the reflect over axis and over y-axis. If we have a number times the function, like 3 times the function or 4 times the function, is going to be stretched by the number. That means you're going to stretch, it's vertical, stretch vertically. That means here is the function. You're going to hold the function from the bottom and stretch it up. How many units we're going to stretch? By this number A. We will see that in an example. Stretched by A. How are we going to do that? I'm going to use the techniques. You're going to multiply each y by A. Y by A. This is really important. You're going to multiply y by A. The same techniques, we're going to do it here. If you have a number, but inside, this number, if you see outside, here, if you have a number inside, so AX, you see the number inside, so it's going to be shrink by A. How are we going to do that with the graph? We're going to divide, not y, x by A. We will see that when we do an example. We divide x by A. This is the techniques. The fifth one is the opposite of both sides. And we will see when we do an example about these two. Let's do an example about stretched by A if we have a number multiplied by the function. Example about that, if we have 3 square root of x. You see, this is the parent function, and there is a number multiplied by the parent function, so it's going to be vertical stretch by 3. So you're going to say it's a vertical stretch by 3. Vertical stretch by 3. You're going to use multiply y by a when we need to graph it. When you need to graph it, you're going to use multiply each y by a to get the new points. Then we're going to graph it to get the new graph. But sometimes they're going to ask you like this. Just have to write down the technique. 3 square root of x is going to be vertical because you see all the techniques here is the vertical techniques. And here is the horizontal techniques. Now let's do another example. If we have 4x squared, 4x squared, you see 4 times x squared, that means here's the parent function x squared, and here's the number multiplied by the parent function. So it's going to be vertical stretch by 4. Let's do the one inside. If we have the square root of 4x, you see the number inside now, inside the root. That's mean inside the parent function. So now it's going to be horizontal stretch, horizontal shrink, because we're working on this side, the number inside. So it's going to be horizontal shrink by 4. Horizontal shrink by 4, because we're working on here, because the number inside. If we have 3x cubed, you see the number here inside the function, inside the cube. So it's going to be horizontal shrink by 3. There's another 2 examples about horizontal vertical stretch when the number is outside, like number 4. Horizontal shrink when the number inside, like number 4 with the horizontal part. Which is the opposite of these 2 techniques. Opposite of techniques 4. If we have, you see here, it's a number, but now we have 1 over the number outside the function. 1 over the number outside the function is going to be opposite than this one. So here is going to be shrink by a. How are we going to do that? If it's a shrink by a, but when we graph it, here, stretch, we're going to multiply y by a. Here, when it's shrink, we're going to divide y by a. So be careful with these 2 techniques when you graph it. A f of x stretch by a. When you graph it, you're going to multiply y by a. 1 over a f of x is going to be shrink by a, you're going to divide y by a. So the graph is going to be shrinked. Like if you have this original graph, it's going to be shrinked, it's going to be smaller. Vertical shrink. The same thing here with number 4. If you have f, but 1 over the number inside the function. So now it's going to be the opposite than this one, is going to be stretched by a. How are we going to do that? We're going to multiply x by a. We're going to multiply x by a. X by a. So these all the techniques, we're going to use it. Let's do an example about the last technique. And then we're going to do examples about all these techniques. The last technique, example about the last technique. So if we have 1 over 3 x squared, 1 over 3 x squared. This is the parent fraction, and 1 over 3, so it's going to be shrink by, be careful, a here, the number here, not 1 over 3. A is the number here, shrink by 3. Now, if we have 1 over 2 square root of x. So this is exactly like number 5, vertical shrink. So it's going to be shrink, or we can write down vertical shrink. Let's write down vertical shrink so we will know. Even here, that means vertical shrink by 3. Here is going to be vertical shrink by a. Here with this one is 2. By 2. So that's the difference between, let's do this one, it's going to be stretched. If we have 1 over 2 x cubed. You see 1 over 2 inside the function and it's cubed, so it's going to be horizontal stretch. Horizontal stretch by the number 2. So it's going to be horizontal stretch by 2. Another example, if we have, let's do one more. If we have 1 over 3 x with the absolute value. You see 1 over 3 inside the absolute value, that's means inside the parent function. So it's going to be horizontal stretch by 3. By 3, the a here is a 3. Let's start examples if we get more than one technique at the same time. So here is examples. If we have 3 x squared minus 2. Let's do it f of x equal, because that's how we're gonna get it. If we have f of x equal 2x squared, let's do it to 3, minus 2. So the first thing, we're not going to graph it, we're just going to write down the techniques. So now here, let's start. Always start from the left to the right to write down the techniques. So the parent function here is the x squared. This is the parent function. Now I have a number outside with multiplication with the parent function. 3x squared. I'm not going to care about this number now. I'm starting with the first technique. The 3x squared, the number is outside the parent function, which is this one exactly like this technique. A number outside the parent function. So it's vertical stretch by A. So the first techniques I'm going to write down, the first techniques is vertical stretch by A, which is the number here, by 3. So I'm done from this technique. The second techniques here, minus 2. Minus 2, this is the parent function minus 2. It's exactly like here. Parent function minus 2. That means shift down. So I'm just going to write down here, shift down. How many units? 2 units. You see, with this example, we get 2 techniques at the same example. Vertical stretch by 3, because there is a number multiplied by the parent function. Minus 2 was going to be shift down 2 units. That's mean 2 techniques at the same time. Let's do another example about that. If we have see now, always when I need to write down the techniques, I'm going to start from the left to the right. The parent function here, this one. This one is the parent function. Now, there is a number outside the parent function with multiplication, a number outside the parent function. So the first technique is going to be exactly like here, vertical stretch by 3. Now, let's go to the second techniques. We're done from this one. The second techniques here, I have a number, but this number with the x inside the parent function, plus 4. So this technique is exactly like here. If we have a number with the x inside, so it's going to be shift to the left. So the second techniques here, shift to left. How many units? 4 units. 2 techniques we're done from this example. So here's another example. If we have negative square root of x plus 4. So we're going to write down the techniques. This is the parent function. I have negative outside the parent function. So that's mean negative outside the parent function. So it's reflect over x-axis. So the first techniques I'm going to write down reflect over x-axis. Now, plus 4 outside the parent function. So this one is going to be shift up 4 units. Done from this one. Let's do another example. 2 techniques. Now let's move on. 3 techniques. Let's do 3 techniques. For example, with the 3 techniques, if we have negative f of x equal, I always forget the f of x. F of x equal negative 1/3 x squared. Just like this. Write down the techniques. So the first thing, I'm going to locate the parent function. Oh, with this one, we need to add one more technique. Plus 3 plus 2. So here's the parent function. Always I'm going to start from the left to the right to write down the techniques. So I'm not going to forget one of these techniques. The first techniques, I have negative outside the parent function. That means this is a reflect over x-axis. The second techniques, I have 1/3 outside the parent function, which is exactly like here. 1/3 outside the parent function. So it's going to be shrink, or you can write down vertical shrink by A. So we're going to write down the second technique is vertical shrink by A is 3, not by 1/3. Be careful. By A, which is the 3. Now we still have one more technique here, which is we have a +2 outside the parent function. So the third technique is going to be shift up 2 units. You see how many techniques do we have? 1, 2, 3. 3 techniques at the same time. If we have f of x -3 x minus, let's do it 2 square plus, that's it. So now always you have to locate the parent function. So the parent function is the x here, x squared. So here's the parent function, but with the squared. So the parent function here is the x squared. Because I have x with parentheses squared, so it's going to be x squared. So the first techniques here, I have negative sign outside the parent function. So it's going to be reflect over x-axis. Now we have 3, a number outside also the parent function. So if we have a number outside the parent function, it's going to be vertical stretch. Vertical stretch by the number here is a 3. Next techniques, it's -2, but be careful here. -2 inside with the parent function inside the square. So -2 inside the parent function. So it's going to be shift to the right. When it's minus the number, it's going to be shift right. So it's going to be shift to the right, horizontal, shift to the right. We don't have to add down horizontal. How many units? 2 units. We're done from this example. Now let's do another example with 4 techniques. It's exactly like the same thing here, but we're going to add one more technique. we have f of x equal negative 1/3 square root x plus 2 minus 4. Then I'm going to give you an example, you can work on it. So the first techniques here, I have negative sign outside the function. Negative sign outside the function. So the first techniques is going to be reflect over x-axis. The second techniques 1/3 outside the parent function, because this is the parent function here. So 1/3 is outside the parent function, so it's going to be vertical shrink by a, because 1/3 outside, so it's going to be vertical vertical shrink by the number a. So here is going to be vertical shrink by a, which is 3. Now let's move on to the next techniques. I have a number, but this number inside the parent function with the x. So the third techniques is going to be shift to the left how many units? 2 units. I have one more technique, -4, which is outside the parent function. So it's going to be shift down 4 units. That's it for this example. F of x equal square root of x minus 2. So you see, they're going to ask you to graph this one by using the techniques. How are we going to graph this one? By using the techniques. So the first thing, I'm going to locate the parent function. The parent function here, this one. This is the parent function. That's mean my parent function, I'm going to say here on the side, y equal square root of x. This is the parent function. And I'm going to graph the new function here on this side. Y equal square root of x minus 2. So this is the parent function. This is the new function. I need to graph it. But I'm going to use this parent function. Now, if you go back to previous section, I already gave you the points and I gave you the graph for this function. F of x equals square root of x. And instead of f of x, there's a y, which is the same thing. Because always keep in your mind, y equal f of x. So every time when you see f of x, that means it's the same thing y. So here is we have the graph for this one. So if you need to graph it, you can use exactly the same points. X, Y, 0, 0, 1, 1, 4, 2. This is X, this is Y, 1, 1, 4, 2. So now let's graph this one here. And we're going to do the same thing here. So we will see the graph, what's going to happen to the graph. So here's the graph for the parent function, 0, 0, the first point. Let's say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We're not going to use this side. 1, 2, 3, 4. 1, 2, 3, 4. So I'm going to graph this graph, the parent function. 0, 0 here. 1, 1 here. 4, 1, 2, 3, 4, and 2 here. So here is the graph for the parent function. If you remember, we graphed it yesterday. Here's the point, and here's the graph for the parent function. Now, I'm going to graph this one. You see these points? These points, I'm going to shift it down 2 units. Because you see these techniques here, shift down. The techniques here, shift down 2 units. That's mean I'm going to shift down each point here. Shift down each point here. So this one, 1, 2, is going to be here. This point is going to be 1, 2 is going to be here. This point is going to be 1, 2 is going to be here. So the new graph is going to be here. That's mean my new graph is going to be shift down supposed to be like this. My graph shift down 2 units. Or you're going to do the same thing here. If you want to shift down the graph, 0 is going to be -2, 1 is going to be -2, 2 minus 2 is going to be 0, is going to be exactly the same graph. But easier for you, here is the original graph. You're going to shift down each point here 2 units. So you get the new graph here. So this is the new graph. This is the graph for x squared. This is the graph for x squared minus 2. Done from this example. Let's do the same example, but now with the x squared. If we have f of x equal x squared plus 2 plus 2. So we're going to do exactly the same. The parent function here is the x squared. So what I'm going to do, I'm going to do exactly the same technique. So I'm not going to do mistakes. So here's, I'm going to say y equal x squared, the parent function. And here I'm going to say y equal x squared plus 2, the new function. Then how to graph this one? I already gave you the point to graph this parent function. X, y, -2 is going to be 4, 0, 0, 2 is going to be 4. I gave you the point yesterday how to graph this one. Choose any x here to get the y, but always, because the domain for this function from -infinity to infinity, so we can choose negative and positive number. The domain for this function 0 to infinity, so I can't choose negative number because it's going to be an I, and this is an imaginary complex number or imaginary number. We can't graph it. So we're gonna graph this one. The domain from -infinity to infinity, that's why I can choose negative number and positive number. It doesn't matter, choose any negative and any positive number, you will get exactly the same graph. So the graph of the parent function is going to be here. Okay, so now let's graph this one, the parent function. -2 and 4, -2, this one, 1, 2, 3, 4. So it's going to be here. Here's the first point. 0, 0, here is the second point. 2 and 4, this is the 2, and here is the 4. So the graph of the parent function is going to be like this. Here is the graph of this function. Now, to graph the new function, what are we going to do here? The parent function, we have 3 points. We're going to shift these 3 points up, shift up, how many units? 2 units to get the graph for this one. So I'm just going to shift this one 2 units. So I'm going to shift it here. 1, 2 is going to be here. Shift this one, 1, 2 is going to be here. Shift this one, 1, 2. This one is supposed to be a little bit wider. Like this. So 1, 2 here. And this one, 1, 2 is going to be here. And this one here. So the new graph is going to be like this. This is the new graph for the new function. Trying to be more accurate. Shift. The new graph is shift. The parent graph shifted up 2 units. You're just going to shift these 3 points. 1, 2, 3. 2 units up, you will get the new graph. So let's do an example about the reflect. If we have alpha for the x equal negative x squared. How are we going to do the graph for this one? So I already have the graph for the parent because the parent function here with this graph is the x squared. So I'm going to say here y equal x squared. And here is going to be the new graph y equal negative x squared. So you will see the difference between these 2 graphs. So now y equal x squared. Let's graph this one. I already gave you the point. X, y, negative 2, and it's going to be 4. 0 is going to be 0. 2 is going to be 4. So let's graph this one. We're going to do exactly the same thing. 1, 2, 3, 4. 1, 2, 3, 4. So negative 2 and 4 is going to be here. 0, 0, and 2, 4 is going to be here. So here is the graph for the parent function. Now, to graph the new function, we just have to do negative outside is reflect over x-axis. What does that mean? That means the whole graph, you're going to reflect it over x-axis. You're just going to take these 2 lines and flip the graph on the x-axis. So this point is going to be stay here. I'm going to take this point and reflect it on the other side. So it's going to be here. And this point reflected over x-axis. You see, this is the x-axis. This point is going to be reflected over x-axis is going to be here. So the new graph is going to be on the other side, like this. That means this is a graph reflected over x-axis. So the new graph is going to be like this. Now let's do 2 techniques. Let's do the stretch and the shrink. So you will see how it's going to be. If you have any questions about this one, you can ask. We're just doing exactly the same techniques, but now with the graphing. So now if we have, I'm going to do like these examples, y, let's do it f of x, which is the same thing. F of x equal 3. To show you what's the meaning of, if you have a number and here's the parent fraction, that means a number outside the parent fraction, a number outside the parent fraction. So it's going to be stretched by a. With the graph, we have to multiply the y by a to get the new graph. I'm going to show you that because this is really important. So the first thing, we're going to do exactly the same steps. We're going to graph the parent fraction here. I'm going to say y equals square root of x, and the new graph is going to be on this side, y equal 3 square root of x. Let's do the table. X, y, with the x squared, the point 0, 1, and 4. So it's going to be 0, 1, and 2. These are the points always we're going to use it to graph the graph square root of x. So I'm going to do the graph right away. And then we're going to do the new graph. 1, 2, 3, 4, 5. 2, 3, 4. So let's graph the parent fraction. 0, 0 is going to be here. 1, 1 is going to be here. And 4, 2, this is 4, and here's 2. So this graph is going to be like this. And here is the parent fraction. This is the graph of x squared, the parent fraction. Now we need to get the points for the new graph. How are we going to get the points for the new graph? X, y. Check here what they're telling you with the notes. Number outside is going to be vertical stretch by a. How are we going to get the new graph? By multiplying y by a. We're going to multiply the y coordinate for the parent fraction by a. So that means the x is going to be exactly the same axis. We're going to multiply the y coordinate by a. A with this example equal 3. So 0 times 3 is going to be 0. Because I need to get the new point. 1 times 3 is going to be 3. 2 times 3 is going to be 6. So I'm going to use these points, x, y, x, y, x, y, to get the new graph. How I get the new points? The x coordinate exactly the same. The y coordinate, I'm going to multiply each y coordinate by a. 0 times 3, 3. 2 times 3 is going to be 6. Now here is the new graph, 0, 0, 1, 3, 4, 6. Graph these points, you will get the graph of the new fraction, and you will see its vertical stretch. Let's see, 0, 0 here, 1, 3, this is the 1, 1, 2, 3, it's going to be here, 4, 6. This is the 4, 1, 2, 3, 4, 6. I need 2 more points. 1, 2, 3, 4, and 6. So it'll be 1, 2, 3, 4, 5, 6. It's going to be here. So you see the new graph like this. This is the graph of 3 square root of x. Check what happened to the graph. It says vertical stretch. That means you're gonna catch the old graph from here and stretch it up. How many units? 3 units. Catch it's a vertical stretch. That means the movement is going to be vertical, up or down. If it's stretch, you're gonna catch the graph and stretch it up. If it's shrink, you're gonna catch the graph and push it down. So it's gonna be smaller because it's gonna be shrinking. Stretch is going to be bigger because you're gonna catch the graph and stretch it up. Shrink, you're gonna catch the graph, push the graph down, it's going to be shrinking. With this case, it's going to be stretch. We stretch the graph. We're going to do exactly the same case, but I'm gonna shrink it, 1/3. I'm gonna do 1/3, and you will see here's the parent function. We're going to shrink it, it's going to be smaller here. So let's do this case here. If we have vertical shrink. So here is E over X. Example is, let's do it, f of X equal 1/3 square root of X. You see, exactly the same number, but I change it. 1/3 is going to be vertical shrink. If you have 1 over the number is going to be vertical shrink by A. How are we going to do that? We're going to divide Y by A. So we're going to do exactly the same thing. Y equals square root of X here. Let's grab this one, XY. And the new graph is going to be here. Y equal 1/3 square root of X. Choose the points, the same points, 0, 1, and 4. And the Y is going to be 0, 1, 2. How are we going to get the Y? Just plug in the X here. The square root of 0 is going to be 0. The square root of 1 is going to be 1. The square root of 4 is going to be 2. So these points is going to be the graph of one, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now let's grab the parent function 0, 0, 1, 1, and 4, 2. I just make it wider than this one. So this is the parent function. Now let's grab this one. We're going to do the table. X, Y. Now, how to get the new table? They're telling you the new table for the new graph, you have to divide Y by A. So we're going to divide Y by A. So the X is going to be the same thing. We're going to divide 0, divide A equal 3, not 1/3. A equal 3, just the number. So 0 divided by 3 is going to be 0. 1 divided by 3 is going to be 0.3. 2 divided by 3 is going to be 0.6. Now let's grab the new point and you will see it's horizontal shrink. My graph is supposed to be, I'm gonna touch the graph from here, on the top, and push it down. Push it down, so it's going to be shrink. 0, 0 is going to be here. 1 and 0.3. 0.3 is less than half. This is the half. So 1 and 0.3 is going to be here. 4 and 0.6. 1, 2, 3, 4. 0.6 is going to be higher than half. It's going to be not here, this is down here. It's going to be here. So you see the new graph is going to be like this. So this is the graph of 1/3 square root of X. And here is the graph of square root of X. You see, it's a shrink, because we touch the graph from the top, push the graph here. So we're gonna shrink the graph to get the new graph is going to be here. How much we shrink the graph? By 3. Number like this, alpha for the x equal square root of 2x. So in this case, you will see this is exactly like this one, because the number exists inside. The number exists inside, that's mean like this. So it's going to be horizontal shrink by a. We're going to divide x by a to get the new graph. So the first thing we're going to do exactly the same techniques. The number a here equal 2. So I'm going to graph the basic function y equal square root of x. And here I'm going to graph the new function y equal the square root of 2x. Let's graph the basic x, y, 0, 0, 1, 1, 4, 2. And the graph of the basic function is going to be here. One, 2, 3, 4, 5, 6. 2, 3, 4, 5. That's enough. 0, 0 is going to be here. 1, 1 here. 4, 1, 2, 3, 4. And 1, 2 is going to be here. So here is the graph of the basic function x squared. Now, let's figure out how we're going to find the graph for this one by figure out the table. So let's create the table here for the new graph. X, Y. Now check. Let's go back to the notes. It's horizontal shrink by A. We have to divide X, not Y, because it's horizontal shrink, because the number exists inside the parent function. So we have to divide X by A. That means the Y is going to be exactly the same. 0, 1, and 2. We're going to divide X by A. 0 divided by 2 is going to be 0. 1 divided by 2 is going to be half, 0.5. 4 divided by 2 is going to be 2. Now let's graph the new points. 0, 0 is going to be here. Half and 1. This is the 1, this is the half and 1. So it's going to be here. Because this is the 1, this is the half. So the x is half and y is 1. Yes, this is right. This is the half here in the middle between 0 and 1. And here is the 1. And 2, 2. So 1, 2, 1, 2 is going to be here. So this is the new graph is going to be like this. Check what happened to the graph. This is horizontal shrink. Horizontal shrink. That means this is the graph. I'm going to push the graph horizontally like this. I'm going to push the graph from here. Push the graph horizontally by factor 2. Push the graph like this. So this point, it's moved to here. This point moved here. And this point moved here. So the whole graph is shrinked by the factor 2. It's called horizontal shrink because we're going to push the graph here. If we want to do stretch, we're going to catch the graph from here and stretch it horizontally. So it's going to be the stretch is going to be wider. The shrink is going to be smaller. That's the difference between shrink and stretch, but this type is horizontally. Let's do one more, for example, if we have two movements at the same time. Two techniques at the same time. So for example, if we have alpha for x equal negative x squared plus 2 or plus 3. Now we have to do two techniques. Always I'm going to depend about the parent function. My parent function is the x squared. So let's grab the x squared here. Then we're going to do the techniques here and here. So I'm going to say y equal negative, so just the x squared. The graph of the x squared, here is x, y. The point negative 2, 4, 0 and 0, and 2, 4. This is the point for the new graph. Now, let's use the techniques about this graph. I'm going to graph it here. Then I'm going to use these techniques and then the other techniques. The new graph, I'm going to use this one technique. So I'm going to say y equal negative x squared here. One, two, three, four, 5. 1, 2, 3, 4, 5. You need 2 more points. That's it. Let's grab this one. Negative 2 and 4 is going to be here. 1, 2, 3, 4. 2 and 4 here. And here is the 0, 0. So here is the parent graph. The graph of the parent function here. This is the x squared. Now let's graph. If I have negative outside the parent function, I'm just going to flip this graph over x-axis. So I'm going to flip this graph over x-axis. So just here's the same point. I'm going to move this one down. So this is 4, 1, 2, 3, 4. With negative 2 is going to be here. And 1, 2 here. So this is the new graph. This is the new graph. This is negative x squared. Now, but we need to graph negative x squared plus 3. So let's graph the last one. Y equal negative x squared plus 3. So this is the next step, the negative x squared. I need to move this graph, the new graph, 3 units up. So the new graph is going to be, I just need to find another marker. Let's do this one. So now the new graph is y equal negative x squared plus 3. I need to graph this one. This is the x squared, negative x squared. I'm going to shift each point up 3 units. So this point is going to be 1, 2, 3. This point is going to be 1, 2, 3 is going to be here. And this point is going to be 1, 2, 3 is going to be here. So the new graph is going to be like this. So 2 techniques. The first technique, we shift the original graph. So we reflect the original graph down over x-axis. Then the next graph, we're going to, here's the new graph now. Shift this new graph 3 units up. So I need to shift this point up 3 units. This point up 3 units. It's going to be here. And this point, the 0, 0, 3 units up is going to be here. So this is the graph of this function y equal negative x squared plus 3. That's if we have two techniques at the same time. So start with the first one, then we get the new graph, go ahead, do the second one. We have two techniques. We're going to shift. Here's the parent function. So I'm going to shift the parent function 2 units to the left. Then the new graph is going to be shifted down 3 units. So the first thing, I'm going to do exactly the same thing. We need to graph the parent function x, y, 0, 0, 1, 1, 4, 2. Then here is going to be the graph of x plus 2. Then the last graph is going to be y equal x plus 2 minus 3. Let's start working here. 1, 2, 3, 4, 5, 6, 7. 2, 3, 4, 5. 1, 2, 3, 4, 5. So let's graph the parent function. 0, 0 here. 1, 1 here. And 4, 2 is going to be here. So here's the graph of the parent function. Now, next step, we're going to graph the first techniques, y equal x plus 2. That means we're going to move this graph 2 units to the left. We need to move this graph 2 units to the left. So I'm going to move each point. This one is going to be 1, 2, is going to be here. This one is going to be 1, 2, is going to be here. And this point is going to be 1, 2, is going to be here. So the new graph is going to be like this. We just shifted to the left. 1, 2, yes. 2 units. Shift this graph to the left 2 units. Then, next step, we're going to shift the graph 3 units down. So the new graph is going to be here. Shift this one down. 1, 2. Here's the new point. Shift this point. No, this one. 1. We have to shift the 3 down. So 1, 2. This is the point. 1, 2 is supposed to be here. 3. Shift this unit 3 units. 1, 2, 3 is going to be here. And shift this point 3 units. 1, 1, 2, 3. It's going to be here. So the new graph is going to be like this. This is the new graph for the function. Here's the point. Shift this point 1, 2, 3. Shift this point 1, 2, 3, and shift this point 1, 2, 3. So the new graph is going to be like this. This is when you move the graph, shifted 2 units, but down. The same techniques is going to be if you minus a 3 plus minus 2 plus a 3 is going to be to the right and up 3 units. So exactly the same techniques. That's it for this section.